Hello everyone, and welcome to another video on scalar fields.
This one's going to deal with how we describe patterns that we see on constant pressure charts and also on surface charts. So I like to describe this talk as how to talk like a TV weatherman. So in other words, this will give you all the buzzwords that you need to have when you go in front of a camera, and there's certain ways of describing, but more so not so much when you are a TV weather person, but actually how meteorologists talk to each other. So if you know this lingo, then you'll be in with the crowd.
So there are several different subject areas that we'll describe or talk about in our description of height or pressure fields. We'll start out how weather systems move, and we'll use terminology that most meteorologists use in describing the movement of weather systems. After that, we'll get into cutoff processes, and then finally we'll wrap up with the intensification of weather systems and the terminology that is used.
So first off, and you probably heard this on the Weather Channel if you watched Weather Channel, but they talk about wind flowing zonally or meridionally. They'll talk about zonal patterns or zonal flow. And the word zonal in meteorological parlance means winds that are flowing from the west to the east. And this is what you normally expect. Of course, weather patterns move from the west to the east, and the winds also move from the west to the east. So in this picture, you can see generally winds are moving mostly from the west to the east. But there are times when really strong weather systems develop, and you'll see winds flowing from the north to the south or south to the north around a trough. And this is what we call meridional flow. And this typically happens when there's very large weather disturbances. A couple other terms that you need to be familiar with are digging and lifting. Digging, it sounds kind of funny, but digging is when a trough has a component of motion. In other words, the whole trough is moving to the south towards the equator. And lifting means that the trough is moving towards the poles. And here's some examples. Here is a weather pattern, and it's pretty much zonal, but you can see there's a meridional component along the west coast where you see the wind moving to the south and then kind of moving up north across Minnesota. So this is a pretty decent sized trough. It's a pretty significant disturbance across the western United States. But then 24 hours later, you can see that the whole pattern kind of amplified and also shifted to the south. So this is a stronger weather system, a strong weather system that is digging. In other words, it's amplifying and moving to the south a little bit.
Our next topic is cutoff weather processes. These are weather systems that cut off from the westerly flow. And to be a little bit more precise about cutoff processes, the glossary of meteorology defines a cutoff process as one where, as it says here, a sequence of events by which a warm high or cold low originally in the westerly flow becomes displaced either poleward or equatorward out of the westerly current. So we're going to look at a couple examples of these. First, let's take a look at the cutoff low, and then we'll look at the cutoff high. The cutoff low, by definition, once again, the glossary of meteorology, is a cold low that's grown out of a trough. It comes out of a trough, and it's displaced out of the basic westerly current, and it's equatorward of that westerly current. So that is a pretty detailed definition. We're going to go step by step through that and look at some pictures and some weather maps. So here we see a cutoff low off the coast of California. This happens occasionally. You see this sometimes. But what this is a 500 millibar map, and you can see that I expanded the view of the cutoff low so that you can see a little bit more detail. And specifically what I'm trying to show you that, number one, this is a low pressure system. Low pressure systems circulate counterclockwise. But also take a look at the temperatures. And you see that in the center of that low, the temperature is minus 20. As you go up farther north to, I guess that's Reno, you see minus 6. Las Vegas is minus 12. San Diego is, I think, like 15. So the center of this low is much colder. This is what they call a cold low. So that's the first part of this definition. Second part, it's displaced out of the basic westerly current. So looking at the strongest winds across the North America, you can see that they enter kind of in British Columbia, move across Montana and Wyoming, and of course North Dakota, and back up into Canada. So that's the main west to east flow, or the westerly current. And this low pressure system is sitting there spinning off the coast of California. So that means that it's not really moving with the westerly current. And then the other part of the definition of a cutoff low, it says, and lies equatorward of this current. So equatorward in the northern hemisphere is to the south. So you can see that this low is south of the main west to east flow, south of the jet stream. So this low pressure system would be classified as a cutoff low. And cutoff lows kind of sit there and spin. They dump precipitation that can affect weather for an extended period of time, perhaps for maybe a week or so. There are also cutoff highs, and by definition, this is from the Glossary of Meteorology again, it's a warm high that has grown out of a ridge and has become displaced out of the basic westerly current and lies poleward of this current. So very similar to the cutoff low, this is just the opposite. It's a warm high that's grown out of a ridge. So what I've drawn here is the flow around the ridge. And you see out of this ridge, you have a closed high pressure or high height at 500 millibars. If you zoom in a little bit closer, it was a little bit difficult to show this, but you'll see that in that high, the temperatures are warmer in that high than the surroundings. They're actually colder. So that is a warm high, and it's become displaced out of the basic westerly current. Once again, if I drew the jet stream, you can see that the jet stream is farther south, going across Canada into the U.S., central U.S., and then exiting the U.S. on the eastern seaboard, someplace around Maine or New Hampshire, around there. So you can see that this cutoff high is not in that flow. And then finally, the definition says, and lies poleward of this current. And that, in fact, is true. You can see that high pressure system is sitting much farther north than the basic westerly east to west flow, or west to east flow. We'll move on to our next topic, which is intensification. So how do we describe the intensification of weather systems?
And then when we talk about intensification, that implies that the pressure gradient is increasing with time or getting stronger. Has nothing to do with the center of the low pressure, but the pressure gradient. In other words, how strong or how close those isobars are. And here's some pictures that show over a period of time an intensifying weather system. And then when we talk about the center of the pressure system going up or down, then we use different terminology. For example, with high pressure systems, they're either building or weakening. If the center pressure is rising, we say it's building. If the center pressure is falling down or decreasing, we say that it's weakening. Now, different terms are used for lows and highs. For lows, if the center of the pressure is going down with time, we say it's deepening. But if the center pressure is rising over a period of time, we say that it's filling.
Another kind of weather pattern that is common are blocking patterns. Blocking patterns happen when they obstruct the normal east to west progress of weather systems on the large scale or the planetary scale. Typically, blocking patterns are evident by the very large, pronounced meridional flow that you see at upper levels. Meridional meaning, of course, that the winds are more or less going north and south around highs and lows, and not so much zonal. This results in weather systems that are pretty much stationary, or maybe they move actually a little bit westward, what we call retrograde. And blocking patterns, of course, persist for a period of time. Usually they'll set up for about a week, but it can be even more than that at times. There are preferred locations for blocks to set up, and they're more common in the spring in the northern hemisphere than they are in the winter, except for the blocking high, which always sets up during the summertime. And you'll find them developing in the eastern North Atlantic, off the coast of Europe, and then also in the eastern North Pacific, off the coast of British Columbia and in the Gulf of Alaska. There are 4 different types of blocking patterns. We'll start out with the cutoff low. The cutoff low, we talked about a little bit about cutoff vortices, so this is the same thing. What happens is a very aggressive trough digs southwards, and with that brings lots of cold air advection. Eventually the cold air wraps around the low, and the low drops out of the westerly flow. So these systems move very slowly, not handled very well by models. Computer models typically try and move them, open them up and move them out quicker than they actually happen. Blocking highs are another kind of blocking pattern. These are very common during the summertime. They almost always set up during the summer. These are responsible, of course, for major heat waves across the central and southwestern and even southeastern United States. You get precipitation around the periphery, but in the high itself, you've got such strong sinking air subsidence that you really don't get any thunderstorms with this. So this sets up thunderstorms around the periphery of the ridge or the high, and that's commonly called, or they call that, meteorologists call it the ring of fire. And that's what's responsible for thunderstorms in North Dakota, typically during July and August, right around the edge of this high, just to the north of the big blocking high is where you get storms, and we see those frequently. These blocking highs are usually broken by cold air intrusions. You get a little short wave moving out, and it weakens the high. Another blocking pattern is the omega block, and they call it the omega block because it looks like the Greek symbol omega, or the Greek letter omega. This, once again, also is a large-scale phenomena, planetary scale phenomena, where you have 2 cutoff lows and 1 blocking high. It may not necessarily be a cutoff high. It might be just a high amplitude ridge. These are very persistent, and the type of weather that you get depends upon whether you're under the lows or under the high. The last type of weather pattern that we'll talk about, blocking pattern, is the Rex block, or they also call it the high over low block. And this is represented by a strong high pressure system over a stronger low pressure system. And as a result, the wind flow is driven up into Canada. As it comes down the high, on the east side of the high, you get northerly flow. So, of course, this is responsible for cold air, persistent cold air across the northern plains. You tend to see this set up a lot of times in January and February. It's miserable for us here in North Dakota. But it also is miserable for people in California because that's where they get those massive floods during the winter. So these are some common terms that are used by meteorologists, and now you now know how to talk like a weather person.